Course 3, we're working with square roots in a somewhat of a review, simpler lesson today, but just really good to keep working on understanding how to work with square roots because it's kind of a new concept when we did learn it. If you were to simplify something like letter A, the square root of 3 can be multiplied by the square root of 12. You don't have to just leave it like that. You can actually make it simpler. You multiply 3 and 12 together and put it under a common radical sign. So the square root of 3 times the square root of 12, you multiply to get the square root of 36, which is a perfect square. 6 times 6 is 36. Now, letter B, we have 42 and 24. Instead of multiplying 42 and 24, I'm just going to put them into their prime parts right away, with 42 being 7, 3, and 2. I'll keep them in order. And 24 being, that's a 4. 2, 2, 2, and 3. Okay. So we pull out our pairs. I see one here. I see one here. And I even see one here. Notice when I pull out a pair, I only pull out the value of 1 in the pair. 2 times 3 times 2, or 12 times what's left had no partner. Sorry, 7, you're staying inside the radical. I'm just copying all the work that they show here. 3 times the square root of 6 times the square root of 15. We can multiply. You've already got a number on the outside. That's a coefficient, not a cubed root. So we leave that on the outside and we multiply the two square roots. 6 times 15, or 2 times 3, right? That's 6 times 3 times 5. Leaving the 3 out of it for now. I've got a pair, so I pull out 3. Making this 9 on the outside. And what's left? 2 times 5. All right, now they're going to apply this to a couple different types of problems here and there, like drawing a rectangle and then finding the area when the rectangle is slanted. All right, like that. You've done dimensions of rectangles like this before by using what theorem? Pythagorean. 1, 2. So to find the missing one, the actual rectangle, you would go 1 squared plus 2 squared is c squared, or the one we want, the hypotenuse. You can tell if it's the hypotenuse by drawing out the square, looking at what's the right angle, right? The legs are A and B. The diagonal is C. So this is 5, which means this line is square root of 5. And that would make, since this is a square, this one's square root of 5. And the reason this fits in with today's lesson is if they ask for the area inside the square, you have to go square root of 5 times square root of 5, which anytime you multiply two square roots that are the same, you get the square root without the sign, 5. You get that number without the square root sign. So why don't you do BDEG? BDEG.